All right, so here is our first look at something called a piecewise function. Before we keep going, though, can you remember what a function is? Well, let me ask you this way. Remember how you did this in one of the first chapters. If I gave you a drawing, if I gave you a graph like this, remember you could tell me if it was a function or not? Is that thing a function, that squiggle?
Yes.
How do you know? Passes the vertical line test, right? So if I had something like, an oval, right? That is not a function because when x is 1, I don't know what the answer is for y. Is it this or is it this? I don't know. Functions, when I plug in a value for x, I can only get one answer back out for y. So I can't ever have two answers along the same vertical line. That is what is not a function, right? This one is, though, because when x is 1, there's only one answer. When x is 17, there's only one answer. So no matter where I go on the graph, if I plug in a number for x, I'll only get one answer out for y. That's how I know a function is a function, okay? So if I look at this thing, this still has to be a function. So I know it's broken up into pieces. Oh, but you will never see them overlap. Now, I know what you might be thinking, but look right here. They overlap there, don't they? They actually don't. See how that circle's open and that one's closed? So if I ask you, what's the value of this graph when x is 0? It's not -1 because that's an open circle. So that's not the answer, it's 3. You get what I'm saying? And nowhere else does it overlap. So that's one thing that you always need to remember about piecewise functions. There's still a function. So they will always pass the vertical line test. Even if I have dots on top of each other, I'll never have two closed dots on top of each other. Right? Don't do this on your paper. But if this were closed, and I said, what's the value of the function when x is 0? Well, now you have two answers, and it's not a function anymore. It's broken. Get what I'm saying? So you'll never have that. If they do overlap, it'll be a dot like this, and one will always be open. Okay? So, but otherwise, that's basically what a piecewise function is. It's a function that's broken into parts. It doesn't just have to be two parts either. You can break it into as many pieces as you want. Okay? Believe it or not, all the absolute value graphs that you have been doing, they really are piecewise functions. They are broken into pieces. It's just the point where they split happens to be the same. So, one thing that we're going to be practicing, I'm trying to find a good one. We'll just use this one. So we're going to be practicing rewriting these instead of absolute values as a piecewise. So there's an equation that gets followed here, and then once x is equal to 4, then you use a different equation to go this way. So do you see how it's a function that's kind of broken into two parts? Yeah. They just don't always have to make a nice V shape. They can make whatever shape they want. But like I said before, they're never going to overlap each other. Because eventually you're going to be graphing your own. And I can't tell you how many times kids graph it wrong and they'll make something like this. Right? They'll have something here and then they mess up and then they do like that. Well, that's not a function anymore. So that's right there should be saying, okay, that can't be right. What they probably meant to do was go this way and not this way. But anyway, we'll get to that in a couple days. Maybe tomorrow. But if we look at this graph, I can ask you a whole bunch of questions. I can ask you something like, what's the value of this function when x is equal to 1? So in other words, what's the y value when x is 1? 2, right? I go to where x is 1. I go up to the graph. Oh, y is 2. See that? What is the value of this function when x equals -3? -3, right? You go to -3, down to the graph. Oh, y is -3. What is the value of this graph when x is 3, 0. Make sense so far? So in this particular one, I have some function that I follow until I hit x is equal to 0. Once x is equal to 0, then I switch to this function and I follow that one. Okay? So in the real world, you might do something like this. We love using a parking garage. So sometimes if you pull into a parking garage and you're there for less than an hour, maybe they charge you, I'm just going to make it up, say it's $2, a $2 fee if you're there from 0 minutes up to 60 minutes. And then once you're there past an hour, maybe they charge you, I don't know, $3 an hour after that. That would be a piecewise function. So I'd have a flat rate for the first hour, and then it would go up every hour after that. I'd pay an additional $2, $3, whatever it is. Make sense? So anything where there's certain conditions. So your data plans on your phones, if you don't have unlimited, right? So for the first, I don't know how much data you get. Okay, say 16 gigabytes. So for the first 16 gigabytes, you pay whatever the fee is. And then, so that's usually a flat fee to get your 16 gigabytes. After that, though, now you're paying, I don't know how much, but a whole bunch of money per gigabyte you go past that. You know what I'm saying? So things like that are going to be reflected as piecewise functions. So under this scenario, you pay this price, and then once you reach a certain point, then you're going to go on to another. They create a new function for you that you probably don't like. So let's take a look at, so that's a graph of 1, okay? If you look underneath where it says algebraically, here's what they look like when we ask you to write them out. This one's a little bit crazier. This one would be 2x plus 8. Isn't that just a straight line? So one part of this graph would be a straight line. The part of the graph that's less than or equal to negative 2. That would be a straight line. In between negative 2 and 3, you're going to have x squared minus 3. What would that look like if I made you graph it? What's x squared minus 3 look like? If it has an x squared in it, what's the graph look like? What'd you say? A U. Those are parabolas. So you'd have this parabola-shaped piece, and then when x is greater than 3, you'd follow this piece, square root graph. When we graph them, they're not going to be this bad. They're just going to be straight lines. But they can look like whatever they want you to do. It doesn't really matter. Now, just because I don't have a graph of this doesn't mean that I can't evaluate it. So let's look at the very first one. They want you to find f of negative 4. So you're just going to take negative 4 and you're going to plug it into the function and see what comes out. Good question. When I plug in negative 4, how many answers should I get out? 1, right? That's the whole point of a function. When I plug one number in, I better only get one number out. But Miss Sabia, there's 3 pieces. Where do I plug it in? Oh, well, you look over here. You look over here. I'm plugging in a negative 4. Is negative 4 less than or equal to negative 2? Yes. Isn't negative 4 less than negative 2? So I'm going to plug it into the top one. It's never going to fit in more than one of these, right? Negative 4 doesn't fit here. It's not in between negative 2 and 3. And it's not greater than 3. So when you go to plug in a value, it will only work in one of these 3. And that's how you know which one to plug it into. So because the x value that I'm plugging in is negative 4, negative 4 is less than negative 2, so I plug it in right here. So when I want to actually evaluate this, I'm going to do 2 times negative 4 plus 8. So it just so happens that that gets me 0. So the value of this function at negative 4 is 0. Just like when I asked you up here, It was just easy because the numbers were nice. I said, hey guys, what's the value of this thing when x is 1? And you all told me, oh, it's 2. It's the same thing, it's just now you're plugging it into the equation itself. So, let's look at f of 6. Are you going to plug it into the top thing, the middle thing, or the bottom thing? The bottom. Does everybody see how they knew that so quickly? I'm plugging in an x value of 6. Is 6 less than or equal to negative 2? No, of course not. Is 6 in between negative 2 and 3?
No.
No. Is 6 greater than 3?
Yeah.
Yes, so that's how you know to plug it in right there. So, square root of 6 plus 3. 6 plus 3 is 9. Square root of 9 is? 3. Cool. Ooh, the next one's tricky though. You say top. But I see negative 2 twice.
Yeah, but the middle one's just less than.
That's right. The x has to be greater than negative 2. It can't be equal to. Here, I have less than or equal to. So I'm going to plug it into the top. So 2 times negative 2 plus 8. What's that, 4? Do you see how this is working? So it doesn't matter how nasty this looks. I'm not going to ask you to graph really bad ones. But that doesn't mean that we can't evaluate them at certain points. You just have to know which one of the 3. I can't tell you how many times the kid takes a test on this and they give me 3 answers for every single one of them. I'm like, you have no concept of what a function is, clearly. Okay? When you plug in one number, you're only allowed to get one number back out. So you would never plug the number into all 3 branches. Why are you doing all that work? I have no idea. How about 0? Yeah, 0 is going to fit in the middle. So I'm going to do 0 squared minus 3, which is just negative 3. Does that make sense? You see how we did that? Okay. Let me see if I want to. The f of 4? Oh, okay. Yeah, so that just means that your answer is 3. So yeah, if you have anything that lands in the middle, the answer is just 3. That's like in the parking garage. You pay $3 for the first hour. So whether you're there 1 minute or 59 minutes, it doesn't matter. You pay $3. So it's that kind of example. Okay? So let me stop this before.